Elevators can give us nightmares, but they can also make dreams come true. On the Persian Gulf in Dubai, sprouting high-rises are transforming coastal desert into a kind of Vegas on steroids. Here, 1/4 of the world's construction cranes are being harnessed to put the city on the global map. Dubai's main attraction is Khalifa Tower, Burj Khalifa in Arabic, the tallest building on the planet. A half-mile high, it's a vertical city filled with apartments, stores, offices, and a fancy hotel. Burj Khalifa has more floors than any other building. And it's got the highest rising elevator in the world.
When you see it just standing there, it's really tough to tell that it's over 800 meters tall, twice the height of the old World Trade Center.
It will take 5 years of construction before this monumental tower can open for business. Rick Pulling from Otis oversees the finishing touches on the elevators, which enable the world's tallest building to actually function.
As buildings reach these super tall heights, we run into the mechanical limitations of elevator technology. We're on the 141st floor, entering the BS machine room, where we have our 100-ton machine. It's the largest machine made by Otis. And when we say 100-ton machine, that's not the weight of the machine. That's the amount of mass that it can support.
As elevators rise higher, cables get longer and therefore heavier. In the world's highest rising elevator, there are 6.5 miles of cables weighing almost 30 tons. Because of this weight, this elevator is approaching the practical limit of how far elevators can go. If elevators continued to rise, their cables would get so heavy, they'd eventually snap under their own weight. And in tall buildings, long cables have other limitations. Skyscrapers sway in heavy winds, making elevator cables vibrate like giant guitar strings, which may cause snags and damage to the walls of the shaft. Motion sensors are installed at the top of the tower to detect sway and slow down the elevators to avoid problems. But slowing elevators creates its own problem because speed is crucial to high-rise living.
The higher you go, the faster you need to go. No one would want to spend 5 and 6 and 7 minutes in an elevator. We can turn the machine as fast as we can supply power. We could be 15 meters a second, 20 meters a second, 30.
But speed must be limited to 8 meters a second in the down direction, so the middle ear has time to adjust to the changing altitude, just the way it does on airplanes.
So while technically we can go very, very fast, human factors, ear pressure say, no, we can't accommodate that. We don't feel comfortable. My ears feel a little bit clogged as a result of this ride.
So elevators can only go so far and so fast. Otis engineers are constantly tweaking and tuning the elevators to push the technology to the limit.
These are really the magicians. They set up the car electrically. They set doors, they set leveling, they set acceleration. Ultimately, the goal is to not know you're moving and yet actually be moving at 8 meters a second through this building.
For tenants paying thousands of dollars a square foot, the ride must be smooth and quick. Inside this narrow spire, 57 elevators are linked with several sky lobbies to carry an estimated 3,500 occupants to and from their floors. 2 elevators are double-deckers, which take passengers to 2 floors at once, effectively doubling their capacity. But even with all the clever engineering, elevators and tall buildings may be reaching another limit.
Most of the super tall buildings today are usually built for vanity reasons, not for real economic reasons. is so expensive to build, and there's so much wasted space with all those elevators. So it's strange that the elevator, which is the necessary thing to make skyscrapers possible, also kind of gets in the way when you get really, really, really tall.
But wherever size matters, the urge to go tall will no doubt persist. As skyscrapers grow higher, people must discover new ways to get to the top in a quest for the elevator of tomorrow.